Alright, please ignore Grey's Anatomy playing in the background here. Alright, airplane traveling at this rate. Oh, the highlighter gets kind of crazy, of course. Altitude, it drops off a box of supplies. Alright, so let's make our XY table. Pause the video now if you haven't done it already. Velocity in the A is entirely in the X, and because of that, the Y velocity initial is 0, because it is all in the X.
You got any plans for dinner? Well, you should come on over. I mean, Catherine's home. You know she makes way too much food.
Delta X, I don't know. Delta Y, negative 500 meters. How long will the box be in the air? Alright, acceleration. I'm looking for time. Alright, probably very visible. Okay, so we're going to use the side that has at least 3, which is our Y. So we're going to say our delta Y is equal to velocity initial in the Y times time plus 1/2 AT squared. So delta Y, we'll plug it in, negative 500 meters. Velocity initial in the Y is 0. So 0 plus anything isn't going to change it there, so we're going to scratch that guy off. Negative 9.81 meters per second squared. T squared. Alright, now we're going to solve for T. Alright, negative 500 divided by 1/2 times negative 9.81 meters per second squared. We'll get rid of this, but notice now we're still in T squared, so we're going to have to square root when we're done. So negative 500 divided by 1/2 times 9.81 meters per second squared. Please notice that if you're dividing by 1/2, it's the same thing as taking it times 2. So it's going to be 1,000 divided by approximately 10. So if you want to watch these ballparking so you don't accidentally, so you catch yourself if you make an accident, I should say. Alright. Let's type this in. So 500 divided by 0.5 times negative 9.81. Alright, then we want to square root that. Oh, dang it. I delete that. I'm not really trusting of this, but I'm going to write it and then type it in again because I'm afraid I might have fat fingered something here. Oh no, it's right. Okay. 10.1. They said 3 sig figs. Let's check. Was it really 3 sig figs? 2 and 1. Ugh, it should be 1. So 10 with no decimal. Crickets. Alright, and there we go. Now we've got our time, so we can use our time to solve for the next material. Done A. Now B, how far away will it land, which is our delta X. So delta x is going to be equal to our v initial in the x times time plus 1/2 a sub x t squared. But remember, because acceleration in the x is 0, we can just scratch that side off and just do that other component there, and we know that our delta x then is going to be equal to 10 seconds times your v initial in the x, oops, which I know it, I just gotta grab it over there. My v initial in the x is 67 meters per second, and times 10 seconds. So my delta x comes out to be 670 meters per second times seconds. Alright, and they had a little higher because their time had that 0.1. Alright, now how far, what will be the velocity when it hits the ground? So we want to know v final, which is going to have an x component and a y component, but we already know the x component. The v final in the x is going to be the same as what it started with because there was no acceleration in the x, which means no change in velocity. So my velocity final in the x is going to be the 67 meters per second. But I need to solve, there, that does go on my screen again. We need to solve for our velocity final in the y. Alright, and we can do that by using any of our equations, but I'd say this is probably our easiest. Initial in the y plus acceleration times time. So my v final is going to be equal to my v initial, which is 0, plus acceleration of negative 9.81 meters per second squared, times 10 seconds. No. So we're going to get a negative 98.1 v final is equal to, we move decimal over 1, negative 98.1 meters per second. Now it's not the final answer because what we actually have to do then is we have to do this vector and use Pythagorean theorem. So this is a, oh shoot, yeah, no, that's it. Okay, so v initial and v final in the x is a 67 meters per second, and tip to tail, remember from way back when, 98, but it's negative meters per second. So my resultant vector is going to be right here, and I can find it just by using SOHCAHTOA, or not SOHCAHTOA, I could, but that'd be excessive. I just need to use Pythagorean theorem, a squared plus b squared equals c squared. So I'm going to take 67 and square it, 67 squared plus 98.1 squared, and then square root of the answer. Gives me 118. That one sig fig, ew. How creative did they get? Technically, they only gave us one sig fig for this problem, so I'm curious what they put in their answer key. 120. They did 2 sig figs. Well, I like 2 sig figs better. So the velocity final would be approximately 120 meters per second. To 1 sig fig, realize, guys, that would actually come out to 100 meters per second. Alright. That is it for number 18.